We're back to inverses of linear functions, so this should be a quick little lesson, and I'm going to try and even show you some more shortcuts that you can do when doing linear functions. So remember, the inverse of a graph means to mirror over the line y equals x. So I have conveniently drawn here the mirror of all inverses y equals x. So how do I quickly plot this point? Well, for the most part, we're going to do y-intercept slope. So my y-intercept is -4. My slope is 3, up 3, 1, 2, 3, over 1, up 3, 1, 2, 3, over 1, and then to roughly give me a line that goes through that. How can we plot the inverse very quickly? Well, for me, whenever I see that they've given me 3 points, I'm just going to reverse those 3 points. So 0, -4 becomes -4, 0. 1, -1 becomes -1, 1. And the lovely 2, 2 is going to remain on the line 2, 2. Once again, let's give myself a quick little line here. And we can see that it's definitely mirrored. And we have done our inverse correctly. Okay, we're pretty adept at finding the inverse of a linear function, but still, let's run through it real quick. The direct method means to switch x and y and solve for y. All right, so I'm going to take my equation up here. Let's switch our x and y. Now let's solve for y. Clean it up. And that's as quickly as I expect you to solve for y. That's an Algebra 1, if not pre-algebra skill. So we see that our answer is 4. Now, I used the direct method, which basically means this. I started with an x. It got multiplied by 5 and then minus 20. So now to inverse that -20, the inverse of that is plus 20. And then instead of multiplying by 5, I would divide by 5. So I'm looking for a plus 4. You have a minus 4, you have a plus 20, there we go. And it makes sense because if I multiply by 5, somewhere along the line I better be dividing by 5. And if I minus 20, somewhere along the line I should have a plus 20. But remember, I took 1/5 of it, that's where I got the 4 from. Now, if you can't do that, that's okay. But I just think I'd show that to some of you who can handle it. Example 2, really quick again. We're going to switch x and y. We're going to solve for y. And once again, right here, please realize that if you have a fraction, the easiest way to undo a fraction is to multiply by its reciprocal. And that would get me 3/2 x minus 12 equals y. And there we are, choice 2. My quick method, what happened to x? It got multiplied by 2/3, and then it got added 8. Now to undo that, we would subtract 8, and then we would multiply by 3/2. So basically the same thing that happened over here. Times -8. Again, let's do that quick canceling, and we get -12, and there we are. That happens to be our only choice with -12. Okay, what is the y-intercept of the inverse? Well, let's get our mind straight. A y-intercept means I am going to put in 0 for the x value, and that will reveal my y-intercept. So there's a couple of ways you could do this. You could say, okay, if I put a 0 in here, that would mean that -9 is my y-intercept, but that's for the function. I want the inverse of the function. So I can't put 0 in for x. Right, the quick way would be to put 0 in for y, because when I reverse it, the x would be in the y spot. All right, so I can just say 0 equals 3/5 x minus 9, add 9 to both sides, multiply by the reciprocal to cancel out that. And once again, hopefully you cancel and you see that your x is 15. So that would be your inverse's y-intercept. Now once again, if that was not sitting well in your brain, if you're still like, I don't get that, you can always do it the long way. You can say, well, I'm going to find the inverse first. I'm going to switch x and y. I'm going to solve for y. And then I'm going to apply the fact that I know if I put a 0 in for x, it will give me my y-intercept. So if I put a 0 in for that x, you will see that I still get that 15. Okay, for the hardest example that they could do is if they don't give it to you in y-intercept slope form, but if they give it to you in point slope form. So I'd look at it this way. Here's my line with a slope of 4, and it goes through the point 2, -6, right? Because we take the opposite. Now the inverse of this would go through the point -6, 2. So if I were to rewrite that in point slope form, I'm looking for y minus 2 equals some slope x plus 6. Now, I know the inverse would be not multiply by 4, but divide by 4. So now I know my slope would be 1/4. Okay, where is this? Here, right there. Choice 1. Now, once again, you could do the whole thing out. You could say, all right, I'm going to make this y equals 4x minus 8 minus 6. So that's y equals 4x minus 14. I'm going to switch x and y. X equals 4y minus 14. I'm going to solve for y now. X plus 14 divided by 4 equals y. So 1/4 x plus 7/2 equals y. All right. Which one of those is that equation? Well, you know it can't be this one because this slope has -4. We know this slope is -4. This slope is -1/4. So we happen to pop into the right one. Now, that one was pretty easy to do. My way, the first way I did it, because they used the point 6. The first function went through the point 2, -6, and we can see that all our choices included those same values. Well, what happens if those weren't our choices? What happens if those were our choices? All right, then we still want to understand that if we're multiplying by 4, the slope of an inverse would be positive 1/4. And the only one here that has a positive 1/4 is number 1. So remember, I can do a quick check to make sure this said the point 2, take the opposite of negative 2, take the opposite of positive 6, which is negative 6, worked on f of x. So I can check myself and know that therefore the inverse must contain the point negative 6, 2. Does negative 6, 2 work in that choice 1? Well, the y value is 2 minus 1. Does that equal 1/4 the x value plus 10? 2 minus 1 is 1. Negative 6 plus 10 is 4. 1/4 of 4 is 1. Yes, it does work.